Hey everyone, I hope you're having a good day. This is Unit 2, Lesson 4. Domain and range of a function, Common Core Algebra 2, non-Regents version. If you don't understand what I'm saying, go ahead and scan that QR code. You can listen to the genius that made these worksheets. Okay, we're going to be talking about functions. Because functions convert values of inputs into a value of an output, it's natural to talk about the set that represents these inputs and outputs. The set of inputs is called the domain. The set of outputs is called the range. Okay, so let's consider the function that has its inputs as months of the year. Wonder what the first month of the year is. January. And its outputs is the number of days in each month. In this case, the number of days is a function of the month. January has so many days. February has so many days. Assume this function is restricted to non-leap years, so February still only has 28 days. Write in roster form. You have to know roster, interval, set builder. Okay, those are the three that we're going to use. Write in roster form the set that represents the function's domain. Domain, range, alphabetical order. Domain, range, input, output, alphabetical order. Domain, alphabetical order. Roster form. List them. January, February. Magic of television, there they are. Write in roster form the set that represents the range. Okay, now let me see. January has so many days, February has so many days, March, April, May, June, July, August, September, October, November, December. Let me see. We have months with, 28. And when we say number of days, we mean the total number of days. We're not going to do, every month has one day. Okay, so 28, 30, and 31. Non-leap year. Are there any months that have 29 days? Don't think so. State the range of the function, 2n plus 1, if its domain is 1, 3, and 5. Show the domain and range in the mapping diagram below. Okay, domain. Domain is 1, 3, and 5. 1, 3, and 5. 1 goes to, let me see, 2 times 1 plus 1 is 3. 2 times 3 plus 1 is 7. 2 times 5 plus 1 is 11. 1 goes to 3. 3 goes to 7. 5 goes to 11. Simple as that. Do I need the arrow? Yes. Yes. This is exactly the way your answer has to look like. The function y equals g of x is completely defined by the graph shown below. It's a function because it says g of x. Answer the following questions based on this graph. It's not a function because it says g of x. It's a function because it passes the vertical line test, because for every x there's only one y. Determine the minimum and maximum values. Determine the minimum and maximum x values represented in this graph. What is x? X is the domain. Minimum x, 1, 2, 3, negative 3. Negative 3, and that's the minimum. 1, 2, 3, 4, 5, 6. Just make sure it's 6. 1, 2, 3, 4, 5, 6. It is 6. That's not a good enough answer. Min is negative 3, and 6 is max. Determine the minimum and maximum y values represented in this graph. Minimum y, the lowest, not here, the lowest. Negative 1, negative 2, negative 3, negative 4, negative 5. Min is negative 5. Max is right there. 1, 2, 3, 4. Highest y value, positive 4. Okay. State the domain and range of this function using set builder notation. Okay, I told you we had interval notation, we have set builder notation, and we have roster notation. We already used roster notation. Now, this says set builder notation. Domain, x's. That's the top one, right? That's the top one. All numbers x such that, let me see, -3 is the smallest, and x is in between, and 6 is the largest. That's the domain. Range. All numbers y such that -5 is the smallest and y is smaller than 4. Close it. If you have any questions, make sure you ask me in class. I'm going to turn the page. Turning. Some functions defined with graphs or equations have domains and ranges that stretch out into infinity, such as this one. Consider the following exercise, which is a standard parabola. Okay, I wouldn't say standard because the vertex isn't sitting on the origin, in which a parabola is graphed. The function f of x equals x squared minus 2x minus 3 is graphed on the grid below, which the following represents the domain and range, written in interval notation. Okay, they're all in interval notation. Domain is the x values. Okay, here's one clue. The x's keep on going this way, keep on going. So we know we have to have a negative infinity with the x's, okay? Here, negative infinity with the domain. Oh, that's the only one that can work. Negative infinity to positive infinity. Keep on going that way, Now, is the range really from -4 to infinity? -1, -2, -3, -4 is the lowest y value. And it keeps on going up on the y value. So choice 3 is the answer. Left and right domain, keep on going to the left, keep on going to the right. That's why it's negative infinity to positive infinity. Notice that they are parentheses because you never can sit on infinity. Okay, I want you to notice that that's a bracket because we are including -4. Okay, this says we're not including +4. That says we're not including -2. Parentheses mean don't include that number. It's an open circle. Wow, I said a lot and you didn't have to write anything down. Parentheses means an open circle, colon, not included. Bracket means closed circle or filled in point. Yes, included. Included in what? Included in the domain or included in the range. For most functions defined by an algebraic formula, domain consists of a set of all real numbers. You can put anything in except when we have a fraction. Okay, given the concise symbol r. Now, let's see what that really looks like, because maybe you can't see it. Okay, meaning real numbers. Sometimes, though, there are restrictions placed on the domain of the function by the structure of its formula. 2 basic restrictions are illustrated in the next few exercises. Right here, there's a fraction, has outputs given by the formula, and is shown on the table. Evaluate f of 1 and f of 6 from the table. F of 1, the function value at 1, the answer is -1. F of 1 equals -1. The function value at 6, is 6.5. Why does the calculator give an error at 4? Let me see. 2 times 4 plus 1, 2 times 4 plus 1 over 4 minus 4. Let me see. 9 divided by 0, divisibility by 0 error. You can't divide by 0. It's a no-no. Don't do it. Can't do it. How can I have 9 fingers in 0 piles? I mean, can you see 0 piles? No, that's why we call it 0. You can't put 9 fingers into 0 piles. What kind of fingers? Butterfingers. Better lay a finger off my butterfinger. Are there any values except x equaling 4 that are not in the domain of the function? Let me look. Nope. They're all there. Why? Because x minus 4 only equals 0 at positive 4. You only have a divisibility error by 0 when it equals 0, and that's only at 4. Which of the following values of x would not be in the domain of this? Let me see. What's special about that? I can take the square root of 3. I can take the square root of pi. I can take the square root of 27. I can take the square root of 16. I can't take the square root of negative 2. So that means x plus 4 has to be greater than or equal to 0, because I can take the square root of 0. Whenever you have a radical, there is a radical, you must set it greater than or equal to 0. You can't take the square root of a negative number. So I subtract 4 from both sides, so x has to be greater than or equal to negative 4. Which of the following values would not be in the domain? Let me see. Well, negative 4 would definitely be there, but negative 8 can't be, because negative 8 is not greater than or equal to 0. When I turn the page, I realize, hey, that's it. This is a wrap, people. Have a great day. See ya.